right, the next joint is the character joint. Uh, Get a share screen going here. So the character joint is kind of interesting because it's designed to act like a ball and socket joint, uh, similar to our shoulder. It has limited rotation about the three axes. The three axes are the dominant and then the first and second swing. The dominant axis is the twist. If we think of a shoulder joint, we can twist, and it doesn't show very well, we can twist our hand. That's the dominant axis. And then we can swing it up and down, and then we can swing it forward and back. These are the axes about which we uh, maneuver the character joint. Each of these axes, well, there's the usual properties, connected anchor, and then the axis, we specify the axis with an XYZ vector, similar to what we did with the hinge joint. The first swing axis is also specified with a vector, so we can then specify a direction for that swing. And the third axis, the second swing, is defined to be perpendicular to twist and swing one. So we don't actually have to define it. It automatically comes up perpendicular to the first two. The twist axis has both high and low limits. So we set a low limit, an angle, a bounciness, and a spring and a damper. The bounciness is how it behaves when it hits the limit, and the spring is what pulls us back to the 0 point, and the damper how it bounces. And we have to set this for both high and low limit. Swing 1 and swing 2 also have a limit, but this is now a plus or minus about 0. So if we specify 30, this is going to go from minus 30 degrees to plus 30 degrees. It also has a bounciness, a spring, and a damper. And of course, it has a brake force, how much it takes to break the joint. Now, I want to show you, I'm not going to make an example of a character joint because they're kind of hard to do, but instead I'm going to show you Unity's tool for making ragdolls. So I have here a whole bunch of characters, and I'll bring in a simple one, Carl. This is the FBX of Carl. This is the thing that's made in Blender or some other program. It's a character who's got animations and other stuff, and I'll just bring him into the scene, and I'll set him here at 0, 0, 0. So he's right in the center. Now, before I make a ragdoll, I want to remove the animator. This is important because if we leave the animator on here and we make a ragdoll, when we try and use it, the animator is going to be doing weird stuff that's going to make our ragdoll behave in strange ways. So I've removed that animator, and I now have Carl in the T-pose, ready to make a ragdoll. Now, the ragdoll we find here from 3D Object. It's one of the pull downs here, ragdoll. And this now opens a little window where we have to find the various pieces of Carl that we want to assign to the different transforms that make up the bones of his body. This is somewhat subjective and requires you to kind of think about things. Our bones are set up as a bunch of a hip, a bunch of legs, a spine, and so forth. Now, the pelvis is usually the top transform in this hierarchy. Sometimes it's called root, sometimes it's called hips, but I'm going to just assume it's hips here, and I'll drop hips into the pelvis. Now I have to look at his leg. We have left hip, left knee, and left foot. I'll just assume that these go down the hierarchy: left hip, left knee, and left foot. And then the same thing with the right leg, right leg, right hip, right leg, and right foot. And now I need to find his arms, which hang off the spine. So here are his arms. There's a shoulder, an arm, and a forearm. I'm going to guess it's a toss-up between shoulder and arm. I'm going to guess left arm and left forearm. I'll put in the elbow slot and do the same thing with the right arm. Right arm, right forearm, the middle spine. So going back here, notice there are 3 spines, so I'm going to guess this is the middle one. And then I have to find his head, which hangs off the neck here somewhere, and I'll pick the head here and drop it in. You can set the mass, 20 is fine, the strength doesn't seem to do anything, and I'm ready to go, and I'll create this. So this created the ragdoll for my character. Now if I look at what this has done, this has now put various joints on the different pieces here. This left arm now has a character joint that is connected to spine 1. It has all of these different properties set up by the builder. You can go in and look in detail at these, but the different all these colliders have been added to my ragdoll, and they all have rigid bodies, and they all have character joints connecting them to each other, and they're all set up properly to make this thing work. Sometimes this doesn't work exactly right. Here, the head, what you can see if you look at the head is that the collider, well, it's actually not that bad. The collider for the head is actually not that bad. So I'm going to go ahead here and now just simply play this. I'll simply play this, and I have a ragdoll, and he falls over and acts like a broken human being. Now, somewhere back a ways, I told you that we were going to replace our character when they die. So let me get back to the beginning of this. Replacing our character when they die. So let me go back into this one. Here I've got my test of a couple of ragdolls that I can, these are ones that I've already made, and I've got my dragger so I can pick them up and fling them around the world. This is always very disturbing in some ways. But these are things that are put together with the character joint. Now, what I want is a character that I can control, but when the character dies, I want it to turn into a ragdoll and collapse into the scene. So I have all these different rigid bodies. They have these simple compound colliders held together with character joints. Uh, and so this is what I just went through the making of the ragdoll, finding the FBX, removing the animator so that it's in T pose, and then creating a ragdoll. The different slots, and this sometimes takes some guessing since the names don't always match up, total mass and strength. And a warning, this is a one-shot deal. There's no going back and editing it. If you get things wrong and the colliders don't look right when you're done, you have to start over again. So replacing the character when they die. This is the my death. I have a public game object, the ragdoll. This is what I'm going to replace my character with. And in the update function, when I press the escape button, it's going to die. It's going to call the die function. In a game, when the character ran out of points, we could just trigger the die function. So the die function is going to replace ourselves with the ragdoll. So the dead object is null. If we have a ragdoll, if there is something in the public game slot ragdoll, I'm going to go ahead and instantiate that ragdoll, calling it dead, at the transforms position with the transforms rotation. These are the position and rotation of our character. So I've created a ragdoll at that point. Now, if I didn't do anything else, here's what would happen. Here's my little character. This is the constructor. So if I just replace him and I happen to be running, it just replaces. And so that's okay if you're just standing still and you replace him. But if you're in motion and you replace him, if we're running and we die, he kind of stops abruptly. So what we want to do is go through the character and first of all catch its velocity so that we know how fast it's moving. And we want to give our new ragdoll components of that velocity. And we also want to go through and recursively copy each element of the character into our new dead transform with the velocity of the character at the point that he or she dies. And then, of course, delete that object. Now, the copy transform recurse is we want our ragdoll not to appear in the T pose that we made him in, but rather in the pose it was in when it died. So we're copying the positions of our character's arms, legs, and so forth when they died into this ragdoll that we're creating. So copy transform recurse takes three arguments: source, destination, and velocity. These are transform, dead transform, and velo. And we get the rigid body components of our destination object. That's the ragdoll. If it's not null, that is, if it's a component that has a rigid body, that's going to be one of the ones that has a collider and a rigid body that's presumably set to be is kinematic. And I'm going to assign its velocity and tell it to use the gravity. Otherwise, I'm going to continue my recursion. I'm going to set its position to the source position and its rotation to the source rotation. And then for each child in that destination, I'm going to continue down through the tree of objects, the children, finding a child, and calling this recursively, so the current source, the child, and the velocity. And this is going to continue down to the bottom of the recursive tree. And that's how this works, how this uh, copies uh, the configuration of my character so that when they die, it catches. That's not the one. This is the one with a copy. So now when he dies, uh, the the new body, the ragdoll, assumes exactly the same pose as the character when he died, and he's flung forward with a bit of velocity. I did pump that up a little bit. I gave him a bit of up and a bit of forward that I added to whatever his velocity is. So when he dies, he's flung up in the air and flung forward a little bit more than when he was moving. He's flung forward and up a little bit. Okay, so I'll show you one more thing, an odd bug. If I forgot to do this, if I forget to delete the player, set active false, kind of deletes the player and leaves just the ragdoll, I get this interesting odd bug, which could be a bug or it could be a feature. Let me take him up here on the hill and stand and look out over the landscape here. And now I'll press escape. And because I'm not deleting myself, I'm making lots of ragdolls. Very funny. Uh, uh, it's a feature, not a bug. All right, so I'm going to stop sharing here and I'm going to end the recording and I'll come back and do the last joint in the next lecture. Bye.